A very warm welcome to everyone. My name is Abhinav Pratap Singh, and today I'm going to present a presentation on the topic OLED display and manufacturing. So, first question which arises in our mind is what is an OLED? So, the acronym OLED stands for Organic Light Emitting Diode, a technology that uses LEDs in which the light is produced by organic molecules. These organic LEDs are used to create what are considered to be the world's best display panels. So let's talk about the origin of these OLEDs. The first OLED device was developed by Eastman Kodak in 1987, and then in 1996 Pioneer Products, the world's first commercial PMOLED, were made. Then in 2000, many companies like Motorola, LG, Samsung, and etc. developed various displays. In 2001, Sony developed world's largest full-color OLED, and then in 2002, approximately 3.5 million passive matrix OLED sub-display were sold, and over 10 million were sold in 2003. In 2010 and 2011, many companies were announced AMOLED display, and many developments took place in the year of 2012. So, first of all, let's know how does an OLED works. An OLED display follows the same principle as a LED display but operates in a slightly different manner. A LED panel requires a dedicated backlighting setting to produce light. However, an LED panel can produce its own light. All this is possible due to specially constructed OLED diodes. And OLED diodes is made of 6 different layers with 2 of them retaining organic properties. When current is passed through these diodes, these organic layers produce light which passes through a color refiner that reproduces picture on the screen. As these panels do not require a backlit setup, TV makers can eliminate the extra bulk and make OLED significantly thinner than LED TVs. So here, as you can see, there are six type of OLEDs, which are passive matrix OLED, active matrix OLED, transparent OLED, top emitting OLED, foldable OLED, and white OLED. So let's talk about structure of OLED. What is the structure of OLED? Organic LED is a solid state device like the LED but composed of several layers. OLED may have 2 or 3 layers of organic material along with other layers. The different layers of OLED are substrate layer. It supports OLED and is made up of transparent plastic or glass film. Anode layer. It is a transparent layer that removes electrons. Indium tin oxide is commonly used as the anode material. Then comes organic layer formed of organic polymers. Then comes conductive layer, which transports hole from anode, made up of organic plastic, polymer light emitting diodes, PLED. Also, light emitting polymers are used in electroluminescent conductive polymer. Typically, polymer used in PLED displays include derivatives of poly and polyfluorine. Then is the emissive layer, which transports electrons from the cathode layer. It is made up of organic plastic. And then the last layer, which is cathode layer, injects electrons, may be transparent or not. Metals such as aluminiums and calciums are often used in the cathode. Then we'll see how an OLED fabrication is done. In general, the OLEDs are fabricated by either a dry process or a wet process. The commonly used dry process is vacuum evaporation. 3 types of vacuum evaporation techniques are reviewed. In wet processes, there are processes for coating without fine patterning and processes for making fine patterns. In addition to deposition techniques of each organic layers, RGB patterning technologies are important. These RGB patterning technologies are vacuum deposition using fine metal masks, wet processes such as inkjet, nozzle printing, relief printing, etc., and laser patterning process. Then comes OLED deposition. So the OLED deposition can be done applied to a substrate using the following methods, which are evaporation and shadow masking, then inkjet printing, and then comes organic vapor phase deposition. So this is the diagram for the evaporation and shadow masking technique, where we can see these two are heaters, and this is the organic material source, and here we can see it is the substrate holder, and this is the shadow mask, as we can see. So now when we come to this inkjet printing, we can see how does it works. Here all the colors are being emitted on these substrates. Now for the third, which is organic vapor phase deposition, We can see how does it works. From it is going and to materials are going from wells to the cooled substrates from the final layer. Then comes the color generation of OLED. Like inorganic LEDs, OLEDs themselves can be made to produce various colors of light. So one form is to simply put red, green and blue OLED materials at the subpixel locations and so produce RGB lights directly. The other way is to use a white OLED material across the entire display area and use the same sort of color filters as are commonly seen in color LCD. Each type has its own advantages and disadvantages. The separated color OLEDs generally provide a wider color gamut but are more difficult, costly to make, and can have problems with different aging rates across the three colors. Color white is somewhat simpler to produce but won't as easily provide the wide gamut many expect from OLEDs. So this is the imagic explanation for the color generation of an OLED. Then the last but not the least which comes is working principle of an OLED. Typically, an OLED is composed of a layer of organic material situated between two electrodes, the anode and cathodes, all deposited on a substrate. The organic molecules are electrically conductive as a result of delocalization of pi electrons caused by conjugation over part or all of the molecule. These materials have conductivity levels ranging from insulators to conductors and are therefore considered organic semiconductors. The highest occupied and lowest unoccupied molecular orbitals of organic semiconductors are analogs to the valence and conduction bands of inorganic semiconductors. So basically, a voltage is applied across the anode and cathode, and then the current flow from cathode to anode through the organic layers, then electrons flow to emissive layer from the cathode, then electrons are removed from conductive layer leaving holes, then holes jump into emission layer, and then electron and holes combine and light emitted. So that's all for this presentation. Thank you for watching.